This video will cover the topic of comparing data. Be sure the date and topic are at the top of your page. The essential question for the video is, how do we read and compare data from visual displays? And when data is collected, it's often presented visually to tell a story. Most often we see that in a line plot, a box and whisker plot, or a stem and leaf plot. I really like using visual data representations when I want a quick snapshot of information, and especially when I want to compare data sets. So I'm going to show you a dot plot as an example of a way that we can compare two data sets visually. Here we have test scores of two different 7th grade classes, and they're in a dot plot, and we're going to see what comparisons we can make. I think I'll start by comparing how many students took the test in both classes. And this is a fairly quick assessment that I can make. I just need to go ahead and count how many of these little pieces of data there are in each class, right? So in class 1, if I count, that's 2 plus 3 plus 4, and so on. I would just add all of these up, and it looks like there are 24 students who took the test. And I'll do the same thing in class 2. I have 1 plus 3 plus 1, etc. And it ends up being 24 as well. So that's my first observation comparing these two data sets. I just checked and they both are the same size. The next thing I'm going to look at is the spread. So class 1, the highest score here is 98 and the lowest score is 82. So their spread goes from 98 down to 82, which means there is a 16-point variation. So the highest student in class 1 had 16 higher points than the lowest student in that same class. At class 2, I'll do the same thing. This time there are some students who are up in the 100s, and there is one student that appears to be down at an 81, which means that that is a 19-point spread. So the highest student got 19 points higher than the lowest student in that class. Which leads me to notice that the spread of data is larger, is wider in class 2 than in class 1. The next thing worth looking at is the median. And if I cut the data in half in class 1, half of the students are above this line and half of the students are below. So that means the median is 87.5, but more importantly, or maybe more succinctly, half the students scored more than 88 points. We'll do the same thing with class 2. And once again, I've marked the median with my pen here, and I see that half the students are above at 90 or more points. And so I'm comparing these classes, and that's another thing that we can declare. We can say the median was higher in class number 2 than class number 1. And lastly, let's look at where the data is clustered. In class number 1, it looks like a lot of the data is right around here, right? There's a lot of information kind of in that 84, 85, 86, 87 range. Whereas in class number 2, it looks like most of the data is kind of around here, right? In that 86 up through kind of that 92 area. So the data is clustered around kind of higher scores in class number 2 than class number 1. So I might conclude here that class number 2 did better on the test, right? With the exception of a few outliers. I would say that class number 2 did a bit better. Let's do this again where we can compare two different set of scores in this case, but we'll look this time with a box and whisker plot. So again, we're looking for what we can notice here. We'll start by comparing how big our sample size is again, but here's the problem, right? Box and whisker plots are great, but there's a flaw. We have no idea how big either of the class sizes are. Box plots only give us 5 points of data. They tell us the minimum, and I'm just labeling it on our box plot up top, so go ahead and do the same. They tell us the minimum and the maximum, right? The two highest and lowest points. The median, the number in the middle. And the lower quartile halfway through the bottom half and the upper quartile halfway through the top half. That's it. So we don't know how many people were in either of these class periods. So let's look at something else we can compare. We can look at the range of scores. So in the first class, right, we know the maximum and minimum. And in box plots, we might have to eyeball a little bit, but it looks like it's about 98 for our highest score way up here, and about 60 for our lowest score, which means there was a range of about 36 points on this test from the highest student to the most struggling student. In period 2, it looks like the highest score is about 95 up here, and the lowest score looks to be 70. So a spread of just 25 points, which tells us the range of scores is larger in the first period than second period. We can also, with our box plot, really quickly compare our median, because our median is nicely marked on both of these, right? So I don't have to even do any calculations. The median is really obvious here. In class 1, half the students got 80 or more, right? The median was 80, and in period 2, the median was 85. So the median score was higher in period 2. Which brings us to the IQR, or the interquartile range. This lets us know where the middle 50% of the kids scored, what a typical score is for half the kids. The IQR, or interquartile range, is nicely found in these boxes here because it is the upper quartile taken away from the lower quartile. So it's from the 25% up to 75% of students, that middle 50% chunk. In period 1, it looks like there was an IQR going from 90 down to 75. So that box, which is 15 points wide, holds half the kids, right? Half the kids were in that 15-point range. In period 2, it looks like it went from maybe 92 to 80, which is an IQR of about 12. Since the IQR was smaller in period 2, that meant that typical score, that middle 50% of the students, the scores were a little bit more consistent, less varied. And beyond that, the IQR is higher up the number line, so it looks like just in general the scores were a little bit higher in second period. So even though I think the highest grade was in period 1, the lowest grade was also in period 1, and I think the middle 50% of the kids, kind of the average, scored a little bit better in second period than first. So I'm going to leave you with one more set of test score data, just because we're on theme here, and I want you to determine which is true. A, B, C, or D. There might be more than one, but looking at the data, can you decide what is true of these three options? And we're going to check that in class together when we go over this in class. So remember that the essential question was, how do we read and compare data? This is asking you to read these two box plots and compare the information that you see there. We'll make sure that we go over this and any other questions you might have in class.